My name is Alex, and today I'm going to be talking to you about building mobile-first web animations in React. So what's a mobile-first animation? I like to think of a mobile-first animation as having three main characteristics. So first, it takes inspiration from design patterns found in native apps, especially thoughtful use of gestures. Second, a mobile-first animation is developed on a mobile device, and it's intentionally designed to work within the context of a mobile browser rather than a desktop one. And finally, a mobile-first animation has great performance, so it works just as well on a mid-range Android phone as on the latest iPhone. So why should we care about this? Native apps use animation in ways that enhance the user experience by creating really fluid, intuitive, and gesture-driven interactions. And there's really no reason that we can't strive to create experiences of a similar caliber in our React web apps. So it doesn't even need to be particularly difficult to apply some of these patterns. So here's a pattern that I'm calling horizontal snapping scroll, and you see it really everywhere on mobile. It's image carousels, tabs, cards, but you see it a little bit less on the mobile web. And for a pattern like this that might not even qualify as an animation, we can actually apply it just with CSS. So there's a scroll snap type property that's pretty well supported in Android and iOS. And on the right, I have the reach tabs component. And I've wrapped it in this CSS to the left with a little extra JavaScript. And I have pretty easy native feeling tabs, which is cool. I will say that scroll snap stop, which gives you a little extra customization ability, is only supported in Chrome right now. So definitely look into this and make sure it meets your use case. But I was pretty excited to learn that I could implement this effect with just CSS. Here's another pattern that you see a lot on mobile, swipe to dismiss. I'm a UI developer, and I think a lot about the way users interact with the apps I build. So I think about button presses, form controls, clicks versus key press, that kind of thing. But until recently, I totally ignored gestures. And swipe to dismiss is a really ubiquitous gesture that it kind of makes sense to be aware of. And one of the things that I think is pretty interesting about it is it comes in a lot of different forms. So it's not really just something that could be implemented by a single awesome React component. It's maybe something that you want to be aware of how to implement from scratch. So I decided that I was going to build some animations to explore implementing swipe to dismiss on the mobile web. And I built these three examples, and we're going to sort of use them to learn some techniques and performance optimizations as we go on in the talk. So my first attempt at building an animation was an animation inspired by the Apple Music app. And I was feeling pretty good about myself when I implemented it, because it looked pretty good as long as I stayed in Chrome DevTools. And here it is. I thought it was pretty nice. I could use my mouse to move the drawer, and I was happy. So I was looking forward to trying this out on a mobile device, and I had just purchased like a cheaper Android phone that I could use as like a testing device. So I loaded it up, and I was pretty shocked at how truly terrible it was. So I noticed like a few issues. I mean, at least a few. There was really low frame rate, so there was like jank and a lag. There was a lot of interference from default browser behaviors, like scroll and swipe to refresh. There was a sluggish response to touch, so I didn't feel like I was directly manipulating what was happening on the screen. And finally, this one's a little bit harder to explain, but it just didn't feel native. It didn't feel like a good animation. So the first thing I want to say is that some of this could have been avoided if I'd just been using a mobile device as my primary development device from the beginning. And ideally, this wouldn't be like, if you have a fancy or high-end phone, you might have an average device that you can use to develop on instead. So I got a Nokia 6 from Amazon. I think it was like 100 or 130 bucks, and I now use that for animations. So it turns out also that it's very easy. Say you just want to look at localhost on your phone. Create React app has been showing me for the years I've been using it, that you can just go to the local IP on your network, and you can see localhost there. I had totally ignored that this was even a possibility, but this is a really easy way to check that whatever you're building works on your phone. And if you want to get a little fancier, I actually prefer USB debugging, which is nice because you don't have to be on the same network. And Chrome DevTools gives you some nice extra stuff, like you can use like the debugger. So that's a workflow tip. In general, I don't want to talk too much about implementation because the truth is we're really lucky in the React community to have several great animation libraries that we can use to implement these animations, and it's not that difficult. So I just want to go through like a few options. There's Framer Motion, which is a really great, a little more all-in-one solution. And if you're like a beginner at animation, this might be the one you want to look at first. There's my personal favorite, React Spring and React Use Gesture, which is a little more like composition-based or gives you like a little more power. It's a little more hands-off. But you don't even have to use those two, which are like the most high-profile React animation libraries. You could use React Swipeable and combine it with vanilla.js animation library like Anime.js that works pretty well with React. Or you could use a sort of battle-tested gesture library for vanilla.js called Hammer.js and combine that with whatever animation library you want. So I don't really want to talk too much about implementation, but I do just really want to really quickly walk through some code to show you that it is pretty easy, and then we can move on to more complex topics. So here, let's build this little like dismissible notification with React Spring and React Use Gesture. And this code is a little bit simplified, but it gets the basic idea across. So we're going to import our hooks, use Spring, and use drag. We're going to set up our Spring. So we're just animating a single variable y, which is basically going to be translate y like 100 pixels, or 0 to 100 pixels, and that will be when we dismiss the notification. This is the use drag hook, which gives us some helpful information. Every time a gesture progresses, we're going to get information about how many pixels the gesture has moved. We can get information like the velocity of the gesture, but here we're doing something very simple. We're just checking the movement y, and we're setting the spring to correspond with that. And if it's the final gesture, which is denoted by the last variable, we're going to decide whether to animate the notification closed or pop it back open. And finally, we just render our notification. We take the onTouchStart listener from the bind function, and we use this like React Spring way of adding our animated opacity and transform values. So that was it. That's how we can render this component. So hopefully that showed you that getting something to move on the screen in React in response to a gesture is pretty easy, but like doing it well is a little bit harder. So I want to take a look at scroll, which is like one of the most basic interactions on mobile, and see what insights we can take from scroll and apply to our own animations. So the first insight is that scroll has an immediate response. It's not really an animation. It's a direct manipulation. And here's a quote from a talk called Designing Fluid Interfaces that was given in 2018 at the Apple Developers Conference. If you're interested in these ideas that we're talking about, I really suggest you check it out because it's really fantastic. So in the talk, one of the speakers said if you do introduce any amount of lag, things all of a sudden just kind of fall off a cliff in terms of how they respond to you. There's all this additional mental burden, and it feels super disconnected. Here's a little illustration of that. I've done a lot of animation on desktop, and to me, on desktop, the left, or the stiff spring, looks fine, maybe even better. But on mobile, we really want to have that one-to-one movement to feel like we're directly manipulating what's happening on the screen. So we don't want to tween the position of the component. We want to have the one-to-one movement. OK, so here's a concept that's a little more complicated. So we can look at scroll decay to help us actually decide how our UIs should respond when a user interacts with them. So you might have used this CSS snippet WebKit overflow scrolling touch to get nice momentum scrolling on an overflowed container. So on the left, we have the default in Safari, which is that as soon as you pick up your finger, the scroll animation stops. And on the right, we have it with momentum scrolling applied. I think in Android, it's by default with momentum scrolling. But yeah, so how is this implemented? Momentum scrolling uses decay. And so I've used like easing functions before for animations. I've used springs, but decay was a new concept for me. And rather than deciding on a fixed endpoint, what decay does is every frame reduces the velocity until the component comes to a stop. And iOS has two default decay rates that you see on the right. There's normal, which really takes a long time to settle, and fast, which is a little bit shorter. So we can use this idea of decay to kind of predict what our users intended. On the right, we have an example that I implemented that has basically 3 potential endpoints from a gesture. the user could have decided to cancel, like maybe they didn't actually want to delete or see an archive option. They could open the 2 buttons, or if they swipe hard enough, they can just directly delete the email. And so Apple's talk gives this little snippet that's pretty interesting called a projection function. And we can basically just take the velocity of the gesture, and we can decide how far this component would have traveled if it was being scrolled rather than animated. And we can use that to inform what we do with it. So here I have a little demo, and we're going to use projection to show the endpoints of the, I guess, list items. So we can take this information, and then when we, oh, that one went a little far. So basically, we use that number, and we decide, like, is it closest to the end, to the archive and delete button open state, or to the full delete state. And that helps us combine information about velocity and gesture distance in ways that make sense to our users. This one is a little bit simpler and more fun. I think rubber banding is something you see, especially in iOS a lot, for scrolling. So rather than having a hard endpoint when a gesture completes, it slowly increases the friction. So it's kind of like gives you a soft indication of where the boundaries of your animation are. So I've used a clamp function a lot when I do animations. Clamp is just take a value, take a min and a max, and make sure it's in between those 2 bounds. That's like really standard. But we can use a rubber band function instead to make sure, so I'll show you. It's not very interesting, but it just stops there, and it stops there, and it doesn't go beyond. But when we add rubber banding, we can make sure that all of the boundaries are sort of gentle. We can add a little squash and stretch if we want. And this is like an effect that's used really commonly on native as well. OK, so we were looking at how an animation should proceed while the gesture is in progress. But at some point, someone is going to finish the gesture, and then what do we do from there? Let's look at how we use springs to make sure our animations work well. So luckily, I don't think I have to like argue that springs are good for UI animation, because that's been a thing in React since React Motion. But I just want to review them really quick in case you haven't used them in a while or used them yet. So the first thing that struck me when I learned about springs was that they're bouncy. And I think that's the first thing that a lot of people notice. So here I have a little demo of the image grid component. And this is what it looks like by default. So I have the damping ratio of the spring set to no bounce. So there's no bounce there. But we can edit this. We can set it to infinite bounce, which I do not suggest. Let's stop that. But yeah, so in general, I think it's really tempting when you learn about springs to like want everything to bounce, but it really doesn't have to. We can still get a lot of benefits from springs with 0 bounce. One thing I did think that was interesting that Apple suggests is using no bounce if it's a tap-initiated animation, and then adding a little bit of bounce if it's gesture-initiated to give a little more movement. So that's bounciness. One of the more interesting things, I guess, is that springs are interruptible. And this is true for desktop animation as well. But when we're building animations for mobile, we really want to make sure that at any point they can be canceled or redirected. It's really important. We don't want to like have to have the user wait basically until the animation completes. And springs help us with that. If we were to use, so I'm going to set the frequency response. We looked at damping ratio, which controls the bounciness. But I'm going to set the frequency response, which controls the speed of the spring. And I'm going to take it from like a normal speed to something super slow. And this is great for developing, because you can actually just pressure test and make sure that you can fully interrupt everything at any time. So like maybe if the user just misses, but then decides they do want to see the thing, you can make sure that that all happens in a fluid way. And the reason springs help us do that is because they're like physics simulations. So they're not, I've used a lot of like CSS easings in the past where you decide in advance on a timing, and springs don't do that. They just take the position and the end position, and then they calculate like how long it should take. So we're not stuck in like always animating something at the same duration, and it feels more natural. And the final thing that I want to talk about with springs is that springs have velocity. And this is really important for our animations. So the material guideline, design guidelines say that when animating an element to a destination, the speed of the user's gesture should be matched by the speed of the element being moved across the screen. Here I have a little simulation of this. We have the gesture velocity set at gentle swipe, but if I move it to crazed fling, you see that the animation changes, and all I'm doing is sending a new velocity into the spring, and it goes faster, and there's a little more of an overshoot, which is great. I didn't have to do anything or change any setting, and it responds to the input that the user is giving. So if I were to change that to ease out, no matter what velocity I set it in, that's not going to change the nature of the animation. So this isn't really great. That wouldn't be great for gesture-initiated animations. All right, so that was the animation best practices part. What did we learn? We learned to look at momentum scrolling as a reference point for the behaviors of our animations. We learned that our animation should really be interruptible and redirectable at any point, which is facilitated by using springs. And finally, we learned that spring animations initiated after a user finishes a gesture must accurately reflect the velocity of the initiating gesture. So now let's look at browsers. So it's fun to think about making the perfect animation in isolation, but eventually we have to actually implement it in a mobile browser. And it turns out that if we're doing gestures, especially, the mobile browser already handles a lot of gestures, such as scrolling, swipe to navigate, pull to refresh, and so on. So we could build the best animation ever, but if it's interfering with what the user actually wants to do, it's going to be bad and probably not worth it. Here's just one example. So on a mobile browser, you can swipe left and right to navigate. This has been a thing in Safari for a long time, and it's behind a flag in Chrome, but it's a gesture that we have to be aware of if we're going to do any horizontal swiping. So luckily, there are some techniques we can use to make sure that our gesture-driven animations coexist with the browser really gracefully. And the first technique is called hysteresis, and this is a UX term borrowed from the physical sciences. And I think it was originally used in UX, maybe to denote that tiny period of time in between when you move your mouse on a mega menu before the menu closes to see if you're going to scroll over some other, or scroll over another part of the menu. So it basically describes intentional lag. And during that lag, the system is getting a little more information, which might be information about the timing or the distance or the direction of a user gesture. So on the right, we have this email list component, and I'm scrolling it up and down in this video. It looks like I'm scrolling side to side, but I'm not. I'm just not able to scroll at perfect 90-degree angles, so I'm unintentionally triggering some animations. And we definitely don't want to do that. So we can add a bit of hysteresis. Here I have a simple function that's basically just ensuring two things. First, the gesture is over some threshold that we've decided on. I'm going to say 15 pixels. And second, it's more of a horizontal movement than a vertical movement. So we can just sort of use a net to catch anything that we don't think was meant to trigger our animation. And with that, we've totally fixed the problem. It's very easy to scroll, and you can trigger the animation if you want to. So hysteresis is easy. Touch cancellation is a little more complicated. When I was first implementing these animations, I thought, OK, cool, I'll just use event.preventDefault. That's what I've used that a lot of times. It should totally work. But unfortunately, we can't really use event.preventDefault for touch listeners. And that's because it requires us to add a non-passive event listener, which is going to kill our scroll performance potentially on mobile. I was a little dubious about this because I really wanted to use event.preventDefault and just move on with my life. So I tested it by adding non-passive touch listeners. And you can see, hopefully, on the left, that it really slows down the scroll. So it's not worth it, because our whole point is trying to increase the interface responsiveness. So if we're hurting performance to do that, it's not worth it. So luckily, CSS has a property called touch action that we can use instead of event.preventDefault. And so touch action all is the default. Just let the browser handle everything. Touch action none completely disables all browser handling of gestures. The ones that you'll probably be using the most are touch action pan X and touch action pan Y, which basically whitelist browser handling of gestures. So pan X is going to disable vertical scroll, and pan Y will disable X-axis gestures. So I was excited to learn about this, and even more excited to learn that we can actually use it, because it was recently introduced in iOS 13. So of course, some browsers still don't have it. For instance, those stuck on iPhone 6s that will never be able to upgrade to iOS 13, which is what I have, but I'm not bitter about it. So let's move on. So touch action is really cool, and I want to show one way that it's really cool. It's smart. So on the left, I have touch action all, and much like the hysteresis example, the user is trying to scroll left and right, but like unintentionally they're doing a little bit of vertical scrolling. And touch action is smart enough to realize that if we've triggered a horizontal movement, we should fix the scroll and disable it until the gesture has completed. And that's actually kind of difficult to implement without touch action. Here's another example of touch action. It's a little more straightforward. So if you disable scroll, a lot of browsers will still respond to your up and down gestures by showing and hiding the address bar. And we can disable that by doing touch action none on the component that's being moved. All right, so what did we talk about? We talked about using hysteresis to make sure that our users won't trigger animations unintentionally. We looked at the touch action CSS property to disable default browser behaviors with precision. And finally, we made sure that we would be aware that mobile browsers have a lot of differences, both in the types of default gestures they implement and their support for properties like touch action. All right, so the final section is performance. Even after implementing some of the things we talked about, the performance of this animation is still pretty bad. You can really notice the lag. And I just want to be clear that I love animation. I look for any excuse to implement them in my own work and at work. But it's really not even worth it doing any of this if your time to interactive is bad and your basic performance metrics are bad. So here's a site that I will not name that I put through the Chrome's Lighthouse audit, and they told me that time to interactive is 10 seconds. I think good is something like 5 seconds. So that's definitely something I should fix before adding animations. But that said, how do we do performant animations? The first tip I have is it's cliche, basically. If you've read anything about performance in animation, you know that you should only be using GPU accelerated properties like transform, just transform and opacity. And that will really make a big difference. It's not just something people say. It will definitely improve the performance of your animations. The second tip is also super simple. So basically, the fewer things you're animating, the more likely you are to hit 60 frames per second. So if you're implementing an animation, think about the minimum amount you can do to still get a nice effect. And maybe you can build from there, but on mobile, you should stay simple if you can. So we were talking about 2 tips to make sure our frame rate is fast as 60 frames per second. But what happens right before the animation starts? Google advises that we keep our response times with under 100 milliseconds. And I was finding in 2 of the 3 animations that I implemented on the lower-end phone, I was not meeting that. So I was noticing that there was a really perceptible lag between when I initiated an animation and when it started. Just to make sure that I wasn't just thinking about this and making it up in my head, I ran the Chrome performance profile, which showed me that indeed there was a pretty long response time, something like 200 milliseconds. You can see the frame rate really drops when all the JavaScript is being run. So I wanted to figure out how to reduce this, obviously, and my first idea was to look for unnecessary React component reconciliation. And the new React Dev tools have this really awesome feature where you can highlight updates when components render. So I turned that on, and I saw that indeed, when I was just clicking on a component, absolutely everything was re-rendering unnecessarily. So I wrapped the components in React.memo and reran it in the dev tools just to check that things had stopped re-rendering. And I could see that now I was only re-rendering the component that I had tapped, basically. And it felt a lot faster. And when I reran the dev tools, the performance profile, I could see that, in fact, the delay had dropped to a really reasonable 60 milliseconds. And the animation was feeling a lot more fluid, a lot more responsive. All right, so that's my talk. What are the main takeaways? First, develop directly on a mobile device. And if you're concerned at all about performance, ideally on a non-high-end phone. Second, start simple and take inspiration from UI patterns in mobile apps. So if you're in doubt, refer to scroll as a basis for how things should move on screen. And finally, when you're adding a gesture-initiated animation, first consider how it will live in the pre-existing world of browser gestures and how you might apply the techniques of hysteresis and touch cancellation. So here's our drawer. On the left was the before. On the right, we've applied all the techniques. It's a lot more responsive. The frame rate is good. And it just feels a little more native. This talk made use of a lot of resources, so I have them in the slide if you're interested in exploring anything further. And if you'd like to look at the slides or the code, you can do so here. So thank you.